But welcome everybody then to this technical webinar on recommended practices for CH4 emission detection and quantification. And we bring this to you today in partnership with the Methane Guiding Principles. My name is Amaya O'Reilly and I lead the Environment and Sustainability Technical Work Programme at the Energy Institute. And I am very pleased to be here today to help moderate this session. So during this webinar, we will focus on the launch of two new resources. The first is the recommended practices for methane emission detection and quantification technologies. And that was developed for OGCI, IOGP and Ipieca, and it's for use on offshore and onshore assets. And then a second resource, which is an extension to these recommended practices that was developed for the Energy Institute and focuses on the quantification of combustion efficiencies and flaring disruptions. And together, these resources really strive to facilitate improved methane management and emissions reporting to help tackle this key aspect of GHG mitigation and inventory. Just before I hand over to Carbon Limits then, which is the consultant that's been very busy preparing these reports for us, I'm just going to really quickly introduce you to the Energy Institute and the Methane Guiding Principles for those of you that haven't worked with us before or been involved in the work that we produce. So, the Energy Institute is a chartered professional membership body for people working within the world of energy. And our mission really is to create a better energy future for our members and society by accelerating a just global energy transition to net zero. And the way we kind of help to meet this mission is by focusing on three main focuses. The first is around attracting, developing and equipping a diverse workforce for the future. The second is around informing decision-making on energy-related issues by convening expertise and advice. And the third is really looking to enable energy to be more sustainable, lower carbon, safer, and more efficient. And one of the ways that we do this practically within the organisation is our EI Technical and Innovation Programme has a huge cross-industry good practice programme where we develop standards, resources, and good practice research. If you're the sort of person that likes getting to grips with these topics and hearing about our publications online, we have a technical and innovation webinar series ongoing at the moment, which this webinar forms part of. And on the screen at the moment, you can see a list of past webinars and future webinars coming up, which really delve into a host of different topics. All of these webinars are recorded and you can find them later on our YouTube page. So if you missed any of them, for example, highlighted in grey, you can click on this link when we circulate the slides later and watch them again. Also, if you want to participate or be part of any of the webinars coming up, then we've got the links on the page and you can click through and register. If you're the sort of person that prefers having these conversations face to face, then just a quick flag that we've got our International Energy Week coming up between the 27th and the 29th of February next year at the Intercontinental London Hotel. And I believe there will be a big panel on methane and methane mitigation. So perhaps some of the topics that we discussed today will be picked up there in a bit more depth. The Methane Guiding Principles then. So the Methane Guiding Principles is an initiative, a voluntary international multi-stakeholder partnership between industry and non-industry organisations that aims to accelerate real reduction in methane emissions from the natural gas value chain. So the Methane Guiding Principles drives effort in 5 priority areas, which are the ones you can see on the screen now, really aiming to reduce methane emissions from natural gas. And then members develop and share practical tools and guidance to help others to learn from their experience and put those lessons into practice. All MGP members, including the Energy Institute, are committed to delivering on 5 guiding principles. Again, the symbols that you can see and the circles that you can see on the screen. Last thing then, before I hand over to Carbon Limits, is just a couple of webinar housekeeping rules. So just to let you know, the webinar is being recorded and will be available on the EI's YouTube page a week after the event. All the participants are muted at the moment except the presenters. So if you do want to ask questions, we'll have 20 minutes at the end for Q&A, but please do pop your questions in the Q&A function only. So that's going to be the section, the place where we're reviewing for questions. So please don't post them in the chat because they won't be picked up then. Without further ado, I think I'll hand over to Carbon Limits to walk us through the webinar.
Great, thanks so much, Amaya.
All right, now I think we can jump right into it. Just a tiny bit more about me and Damon, who will be presenting today. We put our pictures up here so that you don't just see us in tiny at the top of your screen, but you can have a good look at what we look like. So Damon and I are both consultants in Carbon Limits. We both, since the beginning of working in Carbon Limits, have specialized in methane emission mitigation, but also general understanding of methane emissions in the oil and gas sector, as you'll see today. So don't hesitate to ask us questions. We'll do our best to answer it. In Carbon Limits, we don't just work on methane emissions, even though I know that is what you're here for today. We also have other areas of expertise that cover carbon markets and finance, and also carbon capture and storage. So we really cover the whole industrial decarbonization value chain at different levels, from sort of very technical, like we'll discuss today, to some policy or to some financing aspects, so much more broadly. But I think what we're interested in covering today is what we've got on the screen here. So first, as Maya mentioned, so we did have this project with the Energy Institute, which was actually derived from a more general project that we conducted with OGCI, IOGP, and Ipieca on recommended practices for methane emissions detection and quantification technology. So we'll start with that to put a bit of context, and then we'll move on to what you are here for today, which is to look at these flare and combustion efficiency measurement technologies. So we'll go through those. We'll give you a bit of background, also share with you a few spoilers on what we've discovered so far, and then we'll conclude, and we'll have a lot of time for questions at the end. So to start with, this is the first project that we have been working on that sort of sparked this series of other projects. It was made publicly available this week on the IOGP website. So this is first a report that gives a number of recommended practices on methane emissions detection and quantification technologies, where it provides guidance on sort of what to look at when assessing technologies, and also how to use the results that come from these technologies to actually gain a better understanding and reduce methane emissions. It's also accompanied by a filtering tool, which Damon can share with us a bit later on. So this is the structure of the report. So basically, over several months, we have run a number of analyses. We have talked to multiple technology providers. We have talked to the industry, to operators, and we have gone through a lot of literature, discussed with academics, to come up with sort of 3 different tools for operators to use, trying to keep it as practical and hands-on as possible. So the first tool of these recommended practices is a series of decision trees, which we like to call the forest, since there are a lot of them, that we've put together, where we can see how can measurement technologies be used, how can those results be used to achieve a number of objectives that an operator can have. We can detail this a bit further, but things like how do you select a technology, or how do you implement a technology to create your inventory? Moving on from that, in a much more practical way, we have set up a database of a number of technologies that are out there, 51 to be precise, where we've looked at a number of criteria for each of the technologies to try to make them comparable. And all that database has been implemented into an online sort of filtering tool that allows you to select a certain number of characteristics for your sites, because we know that not all technologies are necessarily applicable everywhere. And so it allows you to filter and not have to go through all the technologies, but directly look at the ones that are applicable. Once you click on one of those technologies, you can get access to technology data sheets, which were sort of the most granular level that we reached as part of this project, where in addition to sort of the general information you can infer from the database, you get the detailed information and all the references for those technology data sheets. So what we see here is that for each technology, we looked into a series of information. It's all the same for each technology, so it always follows the same structure to try to make it as comparable as possible. So we give a number of general information. Where is it available? What's the name of the company that is developing this? Is it a service? Is it a product? Very general information just to narrow down already from the start. Then we look at a number of technical specifications. That can be a detection threshold, that can be how often a sample is taken. So a number of things like that that are taken into account. We also look at environmental condition, because we know that deploying a technology, let's say onshore in the US, is very different from deploying it offshore in the North Sea, which is still very different from implementing it in the Delta in Nigeria. We also put information about location. So where is it applicable? Where can it work? We've also looked into deployment information. How easy or how difficult is it to implement? Do I need a lot of training? Do I need to give access to the site to an external contractor to come and set it up? So all those aspects that can also play into the decision-making of an operator. And then finally, if the document was not enough, if you're still curious, there's some links to all the additional information, and everything is detailed and referenced so that you can go back to those to actually get the source raw data from it if it is useful. So here we have the filtering tool, which is publicly available and which has been published. And I can talk about it, but I think it's much easier to understand it and understand how it works if we show it in action. So I think Damon can share with us how this works. And in the meantime, I'll put the link in the chat so that everyone can follow along if interested.
Yeah, great. Thank you. So yes, so this technology filtering tool, so it's publicly available through the IOGP website. So it is a Tableau application-based filtering tool where, so as Manon had said, it details all of the information that are relevant and included in the data sheets. And so as we see here, there's sort of a step-by-step process where a list of technologies are available based on the inputs that are selected for each of these categories. So in general, it goes through information about operator preferences. So if it's if they want to be able to have access to site or not, information on if it's a product that they purchase themselves and deploy themselves, if it's a data product, or if it's a variety of that. There's also high-level sort of filtering of what is the deployment method. So, if that's a satellite, if it's a handheld sensor. So again, very different, but also filterable. Going through information about some of the area characteristics, so onshore versus offshore. I think Manon had mentioned as well, the deployment in these two can vary significantly. So it's also something that we've considered for the data sheets and is included as a filterable option. That's similar with other environmental conditions such as water or snow coverage, where it will either cover information and provide more details about it that it could be filtered out if, you know, if it's something that is preferred not to be included. The deployment level, so that is information about if it's something to be covering multiple sites per deployment, as well as with some of the technology capabilities, if there's a preference that it should be covering a whole at a site level, whether it's should be more granular down to an equipment or component level as well as some more filtering based on, like we'd mentioned, these detection thresholds. So for example, where there's probability of detection curves for some technologies where the 90% probability of detection falls within that detection threshold, it will select only based on those, based on the preferred sort of detection threshold, which again links to decision trees and how they're, based on the aim of deploying the technology and what the overall outcome is, as well as information about technology validation. So where this is, if it's been validated, for example, with third-party testing, with single blind controlled release testing as well. So these are all filterable options. So in theory, so once going through these, through all of these filters, a list of technologies that are applicable for that selection will become visible at the bottom. So where we have provider name, what the technology is, the type of sensor, and then some just again default information about where they operate. By clicking on any of the technologies, you're then taken to the more detailed data sheet where more relevant information is included. And so, as Manal had mentioned before as well, it also provides both the level of the source where the information comes from, links to publicly available information or testing as well. So it really allows for more, it's a more thorough assessment of the technologies, where the information is again available with links to publicly available information. So, and just as an example, if we were to say for deployment methods, so if we're looking at, let's say we're interested in satellite information, just as a very simple example, with selecting satellites, then the available technologies will then be filterable for the satellites, and so you sort of get the idea by now of the applicability of filtering, but a very useful tool that's can be used sort of hand in hand with some of these decision trees and yeah.
Great, thanks a lot, Damon. So I hope this gave you a better idea of what the filtering tool can do and also how to access the technology fact sheets, which can be sort of a good summary of what is publicly available, mixed in with some information given to us directly by the technology providers. But that doesn't always answer the entire question. So let's say you've chosen your technology, you've gone out there, done some observations or some measurements. That's already a great step, but that doesn't necessarily answer your question of, does my site level make sense with my source level when I do quantification, for example? So on top of that, and this is available in the report, we've developed a series of decision trees, which are, let's say, simple yes/no questions that an operator can follow to answer a number of questions. So first, we have this overview tree that, depending on the different objectives, which is either to reduce emissions or to report and reduce emissions, has to go through a series of other trees. So first, of course, you would start with a site and source screening to understand what is present at my site, what should I measure, what should I take into consideration in my inventory. So first, looking at this first aspect. Then the second one is source quantification. How do I quantify methane emissions from my source? Yes, technologies can help in a lot of cases, but not always. It is resource intensive. There are other solutions in some cases some emission sources are best calculated rather than directly sort of quantified through measurement devices. So this tree looks at the different possibilities and how you can sort of play with that and see how things can be adjusted. We also look at site quantification, so what elements need to be taken into account to select a good site quantification technology. We also look into single site reconciliation. This is a big question that is going around a lot in the methane space to understand what is considered good reconciliation. There are several companies and academics that are testing out different methods to work on this. We've tried to boil it down to something practical that can be sort of, I would hope, followed by any engineer, at least to have a general process in mind with simple questions going through, yes, no, what does my situation look like? What kind of information does that say about my methane emissions and my inventory? And then the last one is reconciliation on a group of sites, which is basically similar to what's above, just considering, for example, if we think of the Permian Basin in the US, there have been a number of studies that just look at the entire basin together. So a large number of, let's say, similar sites. How does that work for that? What elements need to be taken into account? So those were the three main parts of the report. As we said, there are 51 technologies that are included in here. But of course, that doesn't cover everything. We looked at detection and quantification technologies specifically for methane. But that's not the only thing that happens on site. There are still a number of other answers and other questions that an operator could have or want to find out. And for that, this is where the Energy Institute stepped in and decided to help us out to add a certain number of technologies to this existing work.
So yes, so the sort of the complementary aspects with an additional scope of work that builds on the recommended practices for methane detection and quantification technologies to include flare, combustion efficiency, and destruction removal efficiency technologies. And so this sort of goes hand in hand with the initial scope of work and provides, I guess, a more well-rounded picture for stakeholders to be informed of technologies that are available and technologies that can be used to measure and quantify methane emission from flares, but in the overall methane as well. So brief note on this is that this scope of work is currently ongoing. We're expecting that it will be made publicly available later this month. And so so everything that we'll talk about for the flare technologies is still ongoing and is waiting for sort of that finalization. But we just wanted to be able to share some of the interesting work that we've found, and it comes at a good time with the initial publication of the OGCI, IOGP, and Ipieca reports. So to jump into the flare recommended practices, providing a bit of brief background for flaring. So in general, it's the burning of undesirable or surplus gas in an open atmosphere flame, where the flared gas will convert the commonly hydrocarbon gases that can predominantly include methane and combusting those to produce carbon dioxide. And so flaring is preferred over the direct venting of methane and flare gas into the atmosphere, because of the global warming potential of methane is between approximately 80 and 30 times more than carbon dioxide over a 20 or 100-year period. So the impacts of combusting it and turning it into carbon dioxide rather than emitting it directly, there is a smaller climate impact. So in 2020, 150 billion cubic meters of gas was flared, and so it's still, what this means is that it's still a large source of potential climate impact, which is why there's been motivations for initiatives such as the World Bank Zero Routine Flaring Initiative, and other sort of more, I guess, more focus on flares as well. The common assumption with flares, sort of, I guess, industry standard, is that an assumption that a normally operating flare will have a combustion efficiency of 98%. And so this is across, so operating properly regardless of any conditions, that is the assumption. But the question becomes a little more, so it gets called into question when there are variations in, for example, with flared volumes. So if the volumes change, what happens to the combustion efficiency, gas composition, the operation of the flare, whether if it's in production flare, low pressure, high pressure, what happens to the combustion efficiency based on the flare design? Is an unassisted flare operating the same as a multi-tip sonic flare? Environmental conditions as well. So when we introduce wind, what happens? As well as with the age of the flare. So a newly installed flare, can it be expected to operate the same as a flare that's been in the field for 20 plus years? And so all of these have an impact on what that potential combustion efficiency could be, hence the need for technologies for measurement and the sort of the overall objective of this recommended practices. Just to provide a brief overview of the deliverables and what will be part of this recommended practices for flares. So first of all, the report that includes a sort of baseline current understanding of flaring emissions, why they're important in the oil and gas industry. The recommended practices will also be similar to the initial scope of work, accompanied by a series of technology data sheets, where again, it's the same process where the information is detailed for currently available technologies for quantifying flare combustion efficiency and destruction removal efficiency, in a series of data sheets included in a technology sort of database as part of a technology filtering tool. So again, it's all based on publicly available information, as well as is publicly available for use for interested stakeholders and anyone in the industry. So I'm going to do this a little backwards, but just to provide right off the bat a few spoilers and key takeaways from what we found out so far, and again, preliminary. The first thing is that the number of technologies for measuring methane emissions as a result of inefficient flares is far less than the technologies for methane technology specifically. So initially we've identified approximately 10 technologies that could be applicable as relevant for combustion efficiency measurement. So when you compare that to the 51 that we'd had in the initial scope of work, there's just a smaller number compared to that. Indirectly related to that as well is that quantification of flare performance is not easy, especially when it's compared to so for methane emissions detection quantification technologies, controlled release testing is relatively simple. I say relatively in quotes because there's still quite a lot of implementation and data collection and work that goes into what's required for this, as you can see in the top image here, with some controlled release testing as an example. But when it's compared to measurements for flare efficiency, where for methane emission methane emission technologies, you can meter the amount of gas that you're emitting, and then that is the control method that you compare to what the technology measures. For flare technologies, it's not as simple because you can't directly meter the flare gas going in and then know the combustion efficiency. It requires a control method that is valid and is accurate. And so the amount of technology implementation that goes into this, so hence why I say it's not easy. Because there is a lot that goes into it. I'm just going to provide sort of a brief overview of some of the techniques and technology applicability for flare combustion efficiency and destruction removal efficiency, and how they relate to potential for either monitoring or measuring flares. So with satellites, we have technologies such as VERS, which are very useful for measuring flared gas volumes using or monitoring flares at night. It also provides a great global coverage of the volume that's flared. However, it's not a direct measurement of the efficiency or emissions of the flares. That requires additional input or assumptions or other inputs to calculate that. There's other certain limitations with inaccuracy with several flares in a single pixel. It can't measure an unlit flare because it's measuring the radiance from the flare. And with satellites as well, when there's high cloud coverage or you can't see the flare because of it, there is a limitation that you just can't see it. Multispectral imagers, so when you think of other satellite technologies, again, so advantage, they will be able to identify unlit flares. There is a global coverage with a variety of technologies, and so they can provide a direct measurement of methane emissions. However, methane emissions does not equal combustion efficiency, so there is no way to quantify this directly. There is also a higher detection threshold than with other methods. For example, when you compare it to an OGCI sensor to be canonical. Similar with the VERS satellites, high cloud coverage, measurements over water, and during daylight hours, there are certain challenges that are introduced with some of these conditions as well. We can look at aircrafts and drones, where, for example, by using both a methane and a carbon dioxide sensor, there can be a sort of the relationship between those can be used to calculate a combustion efficiency or destruction removal efficiency, where they also provide a larger spatial coverage, so potentially, covering several sites at the same time. Without a second sensor, there's a need for knowing the flow rates in the fuel stream, specifically for methane, if it's a single sensor. It also provides a periodic measurement, so it's only measuring when it's at the site, and it might not. So it doesn't provide a holistic annual average because it's not a continuous technology. Could also be potential interferences from other sources of methane, whether that's biogenic, non-biogenic, if it's from oil and gas facilities or other operations in the area. So there are not unovercomable challenges, but they can end up complicating measurements and analysis. I'll talk about spectrometry sort of in a very broad sense. So this could include dial measurements, visor measurements, passive Fourier transform infrared, or hyperspectral spectrometry. But in general, the advantages of these is that there is remote sensing, so it doesn't require direct contact with the flare plume, or within close proximity to the flare. And it can also measure combustion efficiency and methane emissions in general. And I'll say in general again, because some of these technologies could be technically intensive. So I guess you could say it takes a PhD to run these things. So in that sense, it's not sort of an everyday thing you can just pick up and use for measurements. Some technologies are permanently installable for continuous monitoring. On the other hand, some aren't. For measurement of flare combustion efficiency or methane, there's numerical, empirical modeling, which can be used based to calculate combustion efficiency based on measurable parameters, whether that's gas composition, gas flow rate, that also provide calculable uncertainties and can be used to estimate the combustion efficiency or methane emissions. However, the one limitation to them is that there is so they're meant based or to use based on the tested conditions. Using them outside of that could introduce error. While the testing requirements to create these models are labor intensive as well. In a similar vein, we can talk about predictive measurements where there's a use of a closed loop feedback where measurement of correlated parameters that can be used to relate to combustion efficiency. So if that's a heating value, for example. So using these real-time measurements to make changes to the operational status of flares and to either maintain efficient combustion, improve it, so it provides that information. One of the limitations, it requires inline measurements, so such as ultrasonic flow meters. For predictive measurements, the algorithms that are used to derive the combustion efficiency could be based on previous experimental studies or validation with CFD modeling. And so again, this is going back to the previous slide with the control methods to determine the combustion efficiency. There are, again, challenges to it. It also depends on the accuracy of the calculated combustion efficiency is also directly correlated to the accuracy of those measured parameters. So that's in general some of the, looking at some of the technology deployment methods that we covered in the initial scope of work and how, so some of the advantages and limitations of how they can be used for flare measurements specifically. I'm going to move on to the, so moving forward with the structure of the project. So I'll go through this very briefly, but for the datasheet deployment, so same with the initial scope of work, these were based on interviews with providers and with other various stakeholders and input. So whether that's independent research or academic literature, feedback from industry as well. And again, everything based on what we try to make publicly available information, and so that it's that it can be validated and the information is out there as well. The technology data sheets, similar to the initial scope of work as well, they cover very, very similar topics. So general information about it, effects of environmental conditions, the location, so onshore, offshore, different geographical regions, deployment information, so the ease of use, what if there's training required. So these are all questions that we're trying to answer in these data sheets, with the one difference being that the data sheets for flare technologies look at flare specific parameters. So are they, for example, are the technology, is it available to calculate a combustion efficiency? Is it a methane disruption removal efficiency? Is it directly measuring methane? So as well as with accuracy and repeatability of the measurements. So this is all documented as part of that. So the report that goes along with the data sheets and the technology filtering tool provides an introduction, and so with the background on flaring. So I guess you could call it a longer overview of what I provided at the start, review of available technologies, documentation for the data sheets in the database, and how to use the technology filtering tool, as well as sort of a general overview of the sort of the availability of the technologies and the uses of those. So part of the idea with this, with the work for EI, is that these recommended practices, while they are, they've been developed as a sort of a second, following up from the initial scope, but the idea is that these have been developed, that they will still be able to be used as part of the OGCI, IOGP and Ipieca recommended practices document. And so that they're fully integratable and usable with, for example, with the decision trees, where the use of the data sheets and for flare measurements can be integrated into parts of the decision trees for source screening, for source level quantification, as well as for follow-up after reconciliation and continuous improvements for emissions inventory. So
thanks a lot, Damon, for going through that. So here we can actually see how these flare technologies will actually fit in with the initial project that we've discussed about, because they're very complementary. So as Damon just mentioned, we have these decision trees that work basically for any type of technology. If we're talking about a source level flare technology, it can actually be considered just as any other of those source level technologies that are considered in the decision trees. So operators can continue to rely on these to understand how to get the correct data, what to do with that data, how can they leverage it for the objectives that they're trying to reach. In addition to that, so the flare technologies will be integrated in the database, so that it's also possible with just a very simple switch. Does my technology need to be able to assess combustion efficiency or not? Just by selecting that, being able to filter through those technologies directly without spreading over on several different platforms, just having everything centralized in one space. I want to understand my methane. This is the type of tool that I can use. So in addition to those 51 initial technology data sheets, there will be the additional 8 flare technologies that are specific for flaring, that might have some of the information that is specific to flaring included in them, but overall will also follow a lot of the structure and the different parameters that were assessed as part of the general methane technologies. I'm curious here, Damon, to hear from you, what type of parameters were different from the methane technologies that were either different or added, let's say, for the flare technologies?
So that was, so it's with the technology information, the big difference being that rather than providing, for example, a minimum detection threshold for a technology, it provides information about the quantification performance of the flare, so that it both includes, for example, information if there is third-party testing or validation. So what the conditions were, providing an overview of what the uncertainty is based on the repeatability of tests, if that's available as well as off the top of my head, uncertainty, repeatability, quantification performance, as well as other sort of auxiliary but still helpful information. So can it monitor for situations of unlit flaring, for smoke index, heat release, flame size? So these are all, not directly related to methane emissions and combustion efficiency, but it can be used as indicators for, hey, something might be going on with the flare.
Okay, this is great. It's just sort of looking at it from an angle that makes sense to understand sort of the capabilities of those technologies. But now also going back to you about these recommended practices for flares, what sort of conclusions are you, I know it's not finished, but are you sort of going towards? What kind of resources do you feel are available, or what kind of resources will you be able to make available through this work?
Yeah, so I think that probably leads well into so this is our final slide. Thank you all for sitting through and going through this with me. But I think this probably answers that question. So again, this is all sort of preliminary. The report is not finalized and still ongoing. But what we see is that there is an ongoing industry effort to move towards measurement-based inventories where possible, and being able to more accurately. So there's a will to move beyond a 98% combustion efficiency. So I have a few highlights here where recently with in Norway with using dial measurements for flaring to be able to update and provide more realistic emission factors, ongoing flare efficiency studies with BP and Flare IQ technology. There's currently CFD testing at offshore platforms in the UK and the North Sea, as well as more additional experimental testing and empirical modeling out of Carleton University. So many things that are going on. So it's a space that is still changing all the time, but the general trend is that there is a move towards using more updated parameters that are through continuous measurements and to be able to improve that combustion efficiency. So it's not directly related to it, but I also want to highlight the importance of measurements and how it sort of relates to emissions as well. So I think the ultimate goal, regardless of measurements, is that with all sources of methane, is that if you're flaring, you want to make sure that your flare is behaving. So first of all, best way to reduce emissions from flares is reducing the flare gas volume. And so don't flare. So that's assessing whether there are available routes for gas utilization, opportunities, and what forth. So if that's not possible, the next thing is, is the flare operating properly? And so understanding how the flare is performing and using information to understand how to optimize the flare performance and reduce those periods of inefficient flaring. So how can it be made as high as possible, regardless of, so that could be much below 98%, but it could also be much higher in the proper situations. Most of all, if we look at the case right here, the worst possible condition for a flare is when it has a combustion efficiency of 0. So in essence, it's unlit. So those are it's also incredibly important to address those situations as well. And I think that's where the recommended practices for flare efficiency measurements and destruction removal efficiency measurements is complementary to both the initial scope of work through OGCI, IOGP, and Ipieca, but also with other available resources such as the Methane Flaring Toolkit, and it's closely linked with the World Bank Zero Routine Flaring Initiative. So all of these aspects are, moving in the same direction. That so this work is both complementary but also relies on these other pieces of information. Very important. Final thing to say is that, again, project is ongoing and expect to be made available later this year, but I would like to extend an open invitation for anyone who's interested to contribute experiences with available technologies, to look at potential case studies for flare efficiency measurements. All of this information, because we're trying to base it not only off of the theoretical, but also make the information practical and usable. So these are our contact information, and I think that ends it.
Yes, I think we've covered most of the points, although I'm sure we have not covered all the questions that are popping up into your heads right now. So please go ahead, put them in the Q&A, and then I think we can take a go at answering them. If you're wondering, I'm sure a whole lot of other people are as well.
Thank you so much, David and Manon. That was, I'm perhaps biased, but I think this is a really exciting resource that is going to help the industry so much when it comes to quantification of emissions. So you've actually picked up on a couple of the questions already in your presentations, because there was one that came through from Dimitri at Shell around whether the database is complementary to the MGP methane flaring toolkit. So Damon, you just touched on that, but it is a complementary resource. It
is, yeah. So there are similar overlaps with the technologies. The methane flaring toolkit it's comprehensive and includes a variety of technologies as well. So I do see it as complementary.
Fantastic, thank you. One question that I've seen that I think is particularly interesting, and it's come through from Mark Scanlon, is actually around this idea of keeping the tool evergreen. So you've spoken about it being, for example, the flaring side of it not being complete yet, but I'm just wondering, with all the new technologies that are coming out and also those that are updated and discontinued, how would this tool potentially, be kept evergreen and incorporate the evolving technology database?
Yeah, this is a question that we get asked very often. I mean, since the report was published 2 days ago, I think we've already had 3 technology providers informing us of updates, changes. As we were working on the technology database before publishing it, suddenly we got a message saying that one of the technologies was discontinued. So definitely it is a space that is not settled yet. A lot of updates, a lot of new technologies are appearing. So we currently are in discussion to secure some funding to actually keep this evergreen, because we realize the importance of keeping this type of information up to date. So I think it is sort of looking like it's going in that direction now that we have the first version out and available. We will look into following up on this.
Fantastic, great news. Another one from an anonymous attendee then. So just wondering if all the technologies that you've included in the work, are they commercially used by oil and gas companies?
Yes. So what we've tried to identify those technologies that are commercially available as well. So to an amount where I believe all the technologies that we have now have been either tested or deployed in the field, so are in operation. But again, there is more technologies and more methods that are sort of becoming available as well, and I think that's also where the importance of keeping a database like this updated as well becomes invaluable, to sort of keep up with things that are ongoing.
Fantastic. And that kind of picks up on another question that came through around the technology readiness levels of the listed technologies. So you just mentioned that the ones included in the tool, all those technologies have been tested or deployed.
Yeah. So as part of the data sheets, there is no specific analysis of a TRL as part of this, but we have, yes. So, but I think, we've sort of saying with the commercial availability of the technologies as well, indirectly answers the question.
Thank you very much. Another question here that probably maybe perhaps for me. So the question is there a plan to include the flare research results into the EI's Hydrocarbon Management 58 standard covering flaring? You have a deadline for flare research to be completed. So the first bit of the question in terms of incorporating them into the EI standard, yes, there is a plan to try and bring them together. At this point, it's just we're having conversations to understand how we can do this, but it is absolutely on our radar. And then the deadline for the flare research, so as Damon and Manon was saying, we're looking to have this published around October, end of October, November. Whether that is published as an incorporated resource into the recommended practices at this point, I don't know, or if we just get it up and available to people and sort that out at a later date, perhaps. But yeah, this will be up around end of October, beginning of November. And then another question then, again from somebody anonymous that came through, and you did also touch on it a little bit before. So is measurement uncertainty included / discussed in the data sheets report?
Yeah. So I think I did, yeah. This was quantification performance. So that's repeatability, overall uncertainty on the measurement. So including any error or bias in it. And again, so it's also because it's only based on what is publicly available or defensible from the technology providers. So depending on the technology, this information could or could not be available. Again, because there is lots of work ongoing, and so I can't, I don't know, I couldn't give a percentage of what number of technologies have this available, but it is something that we have considered, yeah.
Fantastic, great. That's it for the questions that I've got. Oh no, I've got one more that's come through. The question potentially for Damon. So in practice, how accurate are existing flare technologies to quantify destruction efficiency?
So I guess it depends on the technology. I think if I can speak broadly, not technology specific, but I think the common trend is that when the combustion efficiency is quite high, so when you move above the, say, 96 or 98%, the accuracy of the measurements is very good. When there's a shift towards a more inefficient flare, so whether that it has performance issues or not, if there are specific changes such as with specific conditions with high inert content as well, what we see is the combustion efficiency will be reduced, but also similarly that the uncertainty of the measurement will also increase with that as well. I think that's also sort of it's again important with the what I'd mentioned on the previous slide with the importance of understanding the performance of the flare and having it operate as intended. So when that happens, efficiencies can be 98%. They could also be much higher, and so at that point, it's also where the efficiency is best, and a measurement is most accurate at that point.
Great, thank you. And then we've got time for one more question. So I've got one more left for you, potentially for both of you. So what sources of information did you rely on to develop the technology data sheets?
So this was the same types of sources, both for the initial OGCI, IOGP, and Ipieca reports for general methane quantification detection technologies, and for the Energy Institute with the flaring technologies. So we've relied, let's say, on a diversity of sources. So trying to look into what academic research has been done and has been sort of independently assessed in sort of a more scientific way. What are some of the standards that are out there? For example, if some technologies are accepted by some regulation, sort of assume that they reach certain levels. We've also talked to a number of operators and service providers who regularly deploy or have deployed these technologies to really get a feel of what it is to actually use those technologies in the field. Maybe there are some things that we didn't really think of. Is it very bulky? Is it inaccurate? Is it difficult to deploy? All those different aspects. And then let's say our final source of information was the technology providers themselves, with whom we had sort of extensive dialogue on understanding the capabilities and the, let's say, technical characteristics of their technologies. What was important for us to be able to allow for users of these data sheets to distinguish between sort of what comes from the technology provider, and which might be a bit more on the marketing speech side, but then also see, okay, what has been independently assessed through, for example, testing at METEC, which is a standardized for testing for onshore technologies. So the different levels of assessment and of type of information that has been put into these data sheets is marked very clearly, so that operators also know where this information is coming from, what type of source is backing this up. Is it more independent? Is it the technology providers themselves? Is it a peer operator that has made this type of assessment? So this is sort of the different sources that we rely on in both of the projects.
I think that's a really important point. I think if an operator is going to go ahead and use this, understanding where the information is being collected is critical, especially if they're going to be using it on a wide scale within your operations. Thank you very much, Manon. So I think this is probably the right time to wrap things up. Just again to reiterate, and Sada has written a question to us in terms of when is the flare report going to be released again, as it would be helpful to have the information soon. So just to reiterate, coming out end of October, beginning of November. This webinar will be uploaded to our YouTube page in about a week's time, so you can watch it again, access it there, share it. And I believe the slides will also be circulated and you'll receive them directly in your inbox. So I think let's wrap it up there. Thank you so much, guys, at Carbon Limits for coming and presenting this work to us today. And we look forward to reading the full report. Thanks, everybody.
Thanks, everyone, for your
time. Thanks a lot.
Bye.